decided I don't want to take up the first exercise just yet. I want to give you a chance to try it on your own. So we're just going to do a real simple example. I'm going to use some code, actually the exact same code that I use on those slides in the PowerPoints. I'm just going to make a simple little class library here in C#, just called numFun. And we'll just use it to demonstrate the basic concepts involved here. Okay? All right, so here's my numFun project. Okay, first thing I'm going to do is rename the class. Yes, please do. All right, now I'm going to make it a static. And I'm going to add a method here, a static method. Biggest, right? Returns an integer. I pass in a first integer, a second integer. I determine which one is the biggest, and that's what I return. So I think this logic should work. I'm fairly confident, but obviously I need to do some unit testing to make sure. Now, something that's a good practice I want to make sure you get in the habit of is add summary comments, because they really, really help with the not only the documentation of reading your code, but the IntelliSense that's available as you're coding with these various objects as well, right? So method to determine which number is the biggest. So the parameter named first is the first number. Ooh, I wonder what the second one is, of course. And then what does it return? Well, put this in your own words if you like, but I'm just going to say value of the biggest number, right? Okay. All right, good. So I have my class. Now, does it work? I think it should, but how will I know? Well, let me just right-click on here. Look at that. Create unit test. This is magic, what this is going to do for me. It's actually going to add a second project to the solution. I don't need to change any of those options unless you really want to get in there and change them, right? Notice in the dependencies, it's added a reference to the actual numFun project itself, right? And it's created my first test class here, numFun tests. And then here's a test method for my biggest test, right? Very good. Excellent. Okay. Now, what I'm going to do, again, I'm going to get in the habit with these test methods, right, of adding some summary comments. We mentioned in our discussion earlier that we'll likely be following some predefined, or we'll make them up ourselves, use cases. So here's a good spot to maybe identify that this is going to be a use case, I don't know, 1, right? And I can just define it quickly here. Values will be 5 and 10. And my expected will be 10, right? Okay. Now, we know from experience, you can't have methods with the same name in a class. So one way to avoid getting around that is why not just use the use case, or part of it. Maybe we'll just say case 1 as part of the name here, and that helps avoid that problem. Good. And notice that we right away have assert fail. Very important, because you never want to have a false positive if you can help it, right? So let's come in here and we'll add our basic structure, arrange, act, and finally assert. Oop. Okay. So in terms of arranging, right, I have a static class, so I don't have to instantiate it or new it up, right? But I'm going to prepare variables for the values. Now, I could have gone with first and second, but I don't want people to get the impression that the name I use here has anything to do with the name of the parameters over there. So that's why I'm deliberately using something different this time, right? I'm just going to have A and B, and my expected result is going to be 10, right? So the act itself is pretty straightforward. I'll just call that static method, okay, of my numFun, or number, change name in the middle there, sorry, numberFun biggest, right? Okay, so that's my act. Good. I think I have everything ready now, except, of course, the fact that I still have assert fail. So I'm guaranteed to get a failure every time I run. So my final thing, now I'm ready to replace this. Let's just take a quick look here. Look at all the options. All these overloads are equal based on type and as well as value, not equals, not same, are same, equals, fail, inconclusive, is instance of, etc. So there's a whole bunch of things that are available to us. I'm just going to go with plain old not R equal here. And notice the IntelliSense. Okay, assert R equal. There's an expected. Optional, you can have types. Okay, or actual. So what did I call my expected value? I called it expected. Quite on purpose. And my actual, I called actual. Okay, those are just the names that I use for the variables themselves. Okay, so now this test, I'm happy with it. I think it should determine whether or not, if I pass in this use case, the numbers 5 and 10, I should expect to get 10 back. How do we actually run the test? Well, there's a number of ways, but I can just simply right-click and say Run Test. This will open, okay, the Test Explorer, or sometimes referred to as the Test Runner, right? Now it'll take a moment to do the build, etc. Okay, so we see that in the overall project, okay, we go down and down in, finally we get to an actual test, and here's our summary. Yep, we got a green, it's all passed. Excellent, okay? Now if I want to see a failure, let me just try changing this to 11, okay? By the way, when I can just click run here, but if I want to, I can say run all tests, failed tests, not run tests, pass tests, et cetera, repeat last, and et cetera, or I can go into debug and test and so on as well. But I'll just, at this point, I only have one, I'll just click run. And there we go. Assert R equal failed. Now let me just make this a little bit wider here. Okay, so what do we see? All right. Biggest test, case A1, assert R equal failed, expected 11, actual 10. Now, of course, it's not a real failure, right? Because I changed it. I used the wrong expected value on purpose just to see what a failed test looks like. Okay, so let me put it back to 10. All right, so let's just try. I'm going to move that off the side for a moment. Let's make another use case. What if we swapped these values, right? Okay, so this is my case 2, where I will pass the values 10 followed by 5. Will my expected value change? No. I'm still expecting 10 because 10 is the biggest of the two numbers. Biggest is case A2, or 2, use case 2. Now, I've got to remember to change it. In fact, let me show you this. This is kind of interesting. If I could just do, well, I'll do all tests. Okay, both passed. I have made a boo-boo. I have made a boo-boo. Because this test isn't actually matching what the use case is defined to be. Yes, I got the correct expected result is 10, but I didn't change the order, right? I just wanted to take a moment and do it wrong to drive home a point. This is partially why I said, write small, test small, right? We want to keep our test cases as simple as possible, because even here, it's possible to make a mistake, right? This is essentially a bug in my unit test that I'm not actually testing the test case. So I really should have had assert fail here until I was finished making sure that everything was arranged properly, that the act was appropriate, right? So I should have had assert fail here, then I wouldn't have run into that problem, right? Okay, but I'm going to just fix it now properly so the arrange does match, okay, the test case itself, right? So now I can confidently run everything again. And I'm actually, it's funny you just did the last one. Run all tests. Okay, there we go. So I've run everything, and now I've confirmed that my use case matches the actual arrange, and I'm good. Okay, so maybe that's a cautionary note. If you're going to copy and paste the test, maybe you should put assert fail in there until you've gone through and double-checked everything and made sure. Okay, what if I had a bug in here? What if this had, okay, a logical error like that, okay? Because, you know, a common test might be, let me copy and paste. What if the values are equal, right? So my use, oh, first of all, make sure I put assert.fail. Okay, this is case 3. I'm going to pass 10 and 10. Well, maybe I'll do it different. I'll do 5 and 5. And I will expect 5, right? Okay, so I'll pass 5 and 5. My expected result will be 5. There we go. Biggest, actual. All right, so now I'm ready to replace fail because I've double-checked that the use case, that all the settings in my arrange section are correct according to the use case. So yeah, I'm pretty safe now to go are equal. My expected, actual. Okay, let's run all tests in view. Okay, assert are equal failed on this particular test, right? Expected 10, actual 5. Oh, so we have something going wrong. Well, how can we debug or figure out what's going on here, right? Well, you think, well, you know what? Maybe I better step through execution inside my number fun class here in this biggest method. So I'll set a breakpoint. Okay, that's good. I'll just say run failed tests. Let's see what happens, okay? Okay, it failed, but I didn't hit my breakpoint. I actually have to, there's a couple ways to do it. If I come in and say debug, now you see I've hit the breakpoint, right? So I can stop here. Okay, I see I have 10, I have 5. Do they match? No, they don't. So I'm not surprised to see that I come in here. I saw the else branch because they didn't match. So I'm going to return the second one. Oh, that's a logical error, right? I'm not actually, just because they match each other or they don't match each other, I'm always going to return the second value. Okay, that's not the right logic at all. Okay, I know that's stupid, but I'm just trying to show you how you get into debug. Another option you have is you can also, let me just stop. You can also set a breakpoint in here as well, right? To do that, I can come down here and say debug all tests in view. And then it stops on the breakpoint in the test itself. I can step through execution in the test. When I come here, I'll step into, and that goes into, and I hit the breakpoint here. Now, even if I didn't have a breakpoint, right, it would have come in here, and I can step through execution here as well, right? Just trying to demonstrate the overall debugging approaches that are available to you. Okay, all right. Well, I'm going to set this back the way it should be. Okay, I can take out my breakpoint here and there. And let's just run all tests. And I should be back to passing. Okay. All right, well, that's probably enough of a demo. Oh, maybe I'll quickly throw in, why not? Let's throw in division here. Okay, so division method divides one number by the other, right? Okay, and we have the number you're dividing, the denominator, what you're dividing by, the result, okay, exception of, divide by 0 exception, right? So that's what we should expect, okay? All right, so, oh, I should explain. I've put this in because it no longer raises an exception, right? So if denominator is 0, I'm going to throw my own divide by 0 exception. Arr, okay? If I didn't have that in, I'll show you in a minute. But if I didn't have that in, I wouldn't actually fail the test because they've just gotten too smart, right? Okay, so what kind of a test would we put in here for that? Well, I'll add a test method to the test runner here. All right, so we're going to do our test case 5 here for divide by zero exception. Okay, so I define my numerator, my denominator. Okay, I call my number line division, passing those values, and I put it in a try-catch approach, making sure I get a divide by zero. Okay, there's more than one way I could set this up. Now, if I just say return, right, that will work, okay, and I should get the actual failure, right, if I don't get the exception. Okay, let me test that. Bring this over. Let's not run tests. Same time, only just run the ones that wasn't run here. And there we passed. We passed because we got the exception, right? A couple other things we could do. I could, if I wanted to, I could throw on the expected exception annotation here, and then let it throw the exception. And that also passes, right? So just showing a combination of using a try-catch and using the annotation at the same time. Useless, right? I don't need the try-catch if I'm going to do it this way. But, you know, there's lots and lots of approaches you can combine together. As long as you get the job done in the end, full marks on the test, if you know what I mean. Okay, well, that's probably enough of a demo. I think we'll leave it there. And that should give you a head start on actually carrying out homework exercise 3, the first one on unit testing. I forgot, I promised I'd show you this silly business of divide by zero doesn't actually raise an exception anymore. So I'm going to comment out the logic I added in here to check for that. And let's just repeat the last run. There, see, it failed. Why did it fail? Assert failed because we didn't get the exception we wanted, right? Assert fail. I should have had a message in here. Failed to get the expected exception. Let me just show you that. Okay. There you go. So that's an issue, right? Why is that happening? Well, actually, to make it easier, let's actually make a variable var, just so I can break this down and set a breakpoint. Okay. So we've hit our breakpoint here. Our numerator is 1, our denominator is 0, right? So as I step over, what is the result? Infinity. So that's what they did. They changed it so instead of actually raising an exception, they just give you the mathematical concept infinity instead, okay? So yeah, it doesn't give us a divide by zero exception anymore. Oh well, that's okay. We can handle that ourselves. Anyway, I thought I'd just share that with you.